One of the main key findings in IPF Cell Atlas, this big effort at single cell profiling of IPF lungs, is the discovery that epithelial cells in the lung change dramatically. There's a dramatic decline in alveolar epithelial cells and their replacement by cells on the airways, which obviously cannot do the work of breathing. And one of the most amazing findings, and this was really impressive to us because you don't need to play with the data for these cells to show up, is the presence of cells that we have never seen before. And we call them aberrant basaloid cells. So these are cells that have both progenitor cell features, basal cell features, but not complete, profibrotic features. They can activate fibrosis and a little bit of senescence. And these cells sit at a very unique area, the sort of the edge of the myofibroblast focus, this lesion of pulmonary fibrosis. And what is also interesting, when you do a genomic study, usually are worried about replication. But we could find these cells not only in our data set, but actually in the data set of the group from Vanderbilt and also from groups from Pittsburgh and Northwestern. So again, previously published, these cells were there. Of course, we will need to do cell culture. We will need to develop this. But the finding of a cell type that's unique to pulmonary fibrosis is dramatically important. We also found that other cells are really abnormal. Endothelial cells usually have a very characteristic, people have not, the cells of the lining of the blood vessels, people have not studied them as much in detail in fibrosis. And we found that basically there was a shift in which endothelial cells that are usually at the lining of the airways go into the alveoli. So cells have a unique set of markers, and it's almost like you would say that the lung is being proximalized. Now, this is important because the lung, in a very general way, you could say, has the tubes that basically bring in the air, and then it has the saccules, the alveolar, in which gas exchange happens. So you would think that if cells that come from the airway start filling the alveoli, of course, gas exchange is impaired. And this could explain the shortness of breath and the deterioration of patients with IPF. We found also multiple other abnormalities in different cell types. There has been a lot of talk, and actually this is it macrophages, the large immune cells that are considered what is macrophage, basically big eater. They have a lot of big important roles in pulmonary fibrosis, and this data actually conferred there's an abnormal population of profibrotic macrophages in the human fibrotic lung. There's also a change in fibroblast populations. We did find the ominous myofibroblasts, but we also found invasive fibroblasts. There's also a lot of other changes that we didn't even go in this paper. So to summarize, what we've learned all from this Hubble telescope of cells is the wealth of abnormalities in the IPF lung. But the other thing that we've learned, and that's really important, people think about fibrosis as a non-dynamic process, as something that is stable, like a scar. But actually what we found is that the fibrotic lung is actually extremely active, viable, and dynamic. And this is an important message, because that would mean that potentially with the right drugs, we could reverse this process. Of course, when we do research, the most important thing for us is actually to impact the life of our patients, improve diagnosis and improve management. One of the things that we've been limited over the years is many things we knew about pulmonary fibrosis came from animal models of disease or from low resolution models. We have now 2 drugs that actually slow down the diseases. But what do they actually do on what cell type? By creating this IPF Cell Atlas, this tool which actually describes every single anomaly that is in every single cell type in the lung, we could start designing treatment that actually will reverse fibrosis. Because we could now look at the drug and say, is that inducing the changes that we want in the cell types that we want? This is dramatic. The other thing that we could do is me and others in the field have over the years discovered biomarkers for the disease. There's been a problem with these biomarkers. They have not, although they have been replicated, they've not been implemented widely. And part of the reason is because we never knew what these biomarkers actually tell us. But now, for instance, one of these biomarkers that I discovered many years ago and has been replicated many times, MMP7, matrilisin, we actually know its cellular source. And it's actually not the cells we thought before. It comes from these aberrant basaloid cells. So a drug that will impact aberrant basaloid cells probably would drive down MMP7. So this is just an example, of course. There's many other examples, but by understanding the lung and what happens in the human lung, we could actually start having this plan to reverse fibrosis, to cure IPF. The Mythbuster sessions ended with a discussion by the experts, Dr. Zia Borok, Joyce Lee, and Martin Kolb, and the chairs, Rachel Zemans, Nick Panovich, and Zitin Young. And basically, they were really impressed and expressed their enthusiasm about the whole increase in our understanding of pulmonary fibrosis. They did not necessarily uphold the myth that single-cell technologies will revolutionize the diagnosis and management of pulmonary fibrosis. But most of it was because there was a need for more time and more direct relationship between the finding and potential therapies.